In this video we're going to look more in depth at calculating concentrations involving solutions in titration experiments. So you might want to watch the other video first if you can't remember how to do concentration, moles and volume calculation. So, set up for a titration. Titration can be used basically to find out how much of an acid needs to be added to an alkali to neutralise it, or vice versa. Doesn't have to be acid and alkali, but certainly at GCSE and the initial stages of A-level it usually is. So we would always use a very accurate piece of equipment, a pipette, which has a little filler on the top, which is not shown here, and that normally has one line just for measuring one volume, for example 25 centimetre cubed of acid in this case. That's then put in the flask. So we're putting something in the flask, and that's normally the solution that we don't know the concentration of. So we're going to focus today on using this to find concentration of a solution rather than using it to make a soluble salt. And then the other piece of very accurate measuring equipment we have is a burette. And a burette, of course, is just like a long pipe, granulated cylinder with markings all the way along for making readings, tap at the bottom so that you can add your alkali. And the burette does not have to be filled up to 0, which means that in some experiments you would read the first reading on the burette at the top, and then you read the second burette reading, you take them away, and that tells you how much of your alkali you've added to your acid. We then add a bit of indicator because we need to know when the reaction changes colour. That's going to tell us the end point because my acid and alkali are colourless. So we would then add our sodium hydroxide, having read the first reading on the burette until the indicator changes colour, take a final reading, and we would probably do this experiment 2 or 3 times. It's not random, we do it until we get concordant results, and we're going to look at that and what the results table looks at like in a moment. So let's have a look at an example question. The nicest part of this question is just looking at a reading from a burette, so fabulous. And at GCSE level they're going to give you some nice clues. They're going to tell you, give the readings to the nearest 0.05. They don't do that at A level, you're going to have to work it out yourself. You also need to read the table carefully. The table is written in a peculiar order because the table says, the first bit of the table says burette reading after adding the acid, and then the next line says before. We'll write those down and then we'll work out why it does it that order. So let's read the after one first. Now burettes read down, there's 23 and there's 24. So I'm reading down, this is 23.5, this is 23.6. However, if I wrote 23.6 like that, that's my first mark lost in the question, and that's because it says the nearest 0.05, which is 2 decimal places. So it's 0.60. What I'm saying is it is exactly on the line. It's not halfway between 23.6 and 23.7. If it was, I'd write 23.65. So I can't read lots of little divisions, but I can tell whether the line, the liquid, is directly on one of the measurements or if it's halfway. If we look at the before, that gives us a better idea of what we mean. So the before, we're reading the bottom of the line, the meniscus here, so we're not reading that little curly bit. We're going downwards, so it's 2.5, 2.6, 2.7, and then a half. So it's going to be 2.75. So we have decimal place readings there. And then the reason that we put the before value at the bottom of the table and the after value at the top is simply to make it easier to take the 2 numbers away. Having said that, you've got a calculator, so use your calculator. Nothing sillier than throwing away the 3rd mark just because you couldn't be bothered to put it in a calculator when you had one there. So I put it in the calculator and I end up with a value of 20.85. So when we're doing a titration, this is what we're trying to find. We're trying to find the volume of acid needed to neutralise an alkali, or vice versa. Different question. So this time they've given you the final volume in acid added, and they've given you 4 experiments, and they've asked you to work out which ones are concordant. And at GCSE they're telling you that that means they have to be within 0.2 centimetre cubed of another. A level, again, they don't give you that information anymore. So which results are concordant with one another? So let's look at the first 2 results, 22.9 and 22.6. There is 0.3 between them. If I take them away from each other, the difference is 0.3. They are not concordant. 22.6 take away 22.45 is 0.15. So those 2 do agree with each other. And then if I compare the difference between 22.45 and 22.55, they are 0.1 away from each other, and also 22.55 is only 0.05 from 22.6. So all 3 of these readings are less than 0.2 centimetres cubed between them. So it can be up to 0.2. What they won't do is give you like 3 results which are 0.2, but then one of them is like 0.4 from the other. They won't do that, so don't worry about that. It will be fairly obvious. Once you've done that, of course, you can calculate a mean simply by adding up those 3 numbers and dividing by 3. So I add all of those up, divide by 3, and I get 22.53 as my mean volume. I'm not going to do it to any more than 2 decimal places because I've only got 2 decimal places in my results, and that is centimetres cubed. So don't forget to put in the units, especially if you're given 2 marks. Obviously there must be another mark somewhere. So you'll notice that they keep changing this and going, oh, this time this is a different experiment. They do this so that they don't have to keep marking your mistakes and checking for your different numbers every time. So they give you new information. And we said we've got some pieces of information here. Got volume of sulfuric acid, concentration of sulfuric acid, and then a volume of lithium hydroxide. So that would be what you found out in the experiment. It'll always have one number which is a very even number, so I've got my 25. That means that we used a pipette to take that out. We've always got a concentration of one of the substances, pretty much always. So we've got 2 pieces of information about the acid. We've got 1 piece of information about the lithium hydroxide, and we're going to use it to find the missing piece of information about the lithium hydroxide. So I got 22.85 for that. So this question is a GCSE question, so it is stepping it through rather than asking you to work it all out in one go. And the first thing it's just given you is work out the number of moles in 25 centimetre cubed. So I've got volume, concentration. So that's nice. They've reiterated the numbers so that you don't have to pick them out of the question. A higher level question would ask you to find the numbers yourself. You wouldn't be then given them again in the question. So the amount of moles, well, if I know that concentration is moles per dm cubed, then to find moles, rearrange it, concentration times dm cubed. So my concentration is 0.107. I don't have volume in decimetre cubed, I have it in centimetre cubed, so I have to go 25 over 1000 equals 0.025. So I'm going to do that times by 0.025. That will give me my amount in moles. That gives me a number in standard form. That's alright. 2.675 times 10 to the minus 3. And I'm going to leave it in standard form because I'm much less likely to go wrong if I just write it exactly as it is on my calculator. I'm going to keep it in my calculator as well. So this is the question that we've just done, so let's just pop that back in so remember what the answer is, because we're going to need the answer for the next bit. So the next bit says calculate the amount in moles of lithium hydroxide. So we're moving from the moles of the acid, which is up here in the balanced equation, to the moles of the alkali. So we're going to use the relationship from the balanced equation. So the equation tells me that there are 2 lithium hydroxides for every 1 H2SO4, and I worked out in the previous question 2.675 times 10 to the minus 3 was how many moles of H2SO4, so I need to times it by 2 to get my moles of lithium hydroxide, and that would be 5.35, also times 10 to the minus 3, leaving it in standard form. So I now know moles of lithium hydroxide. Again, it's stepping me through, so I know what the next is going to be, writing that in there. Next step is using that moles of lithium hydroxide to calculate the concentration in moles per dm cubed. And up here we've got a reminder of the volume of the lithium hydroxide. So let's go back to what concentration equals. Oops, I do this every time. Concentration is equal to moles over dm cubed. Moles is 5.35 times 10 to the minus 3. dm cubed, well, I've got 2.85 centimetre cubed, so I need to divide that by 1,000 like I did before, 0.02285. So these are going to be really small numbers that we deal with in titrations. We deal with very small volumes of very dilute solutions. So I'm not looking for any big numbers anywhere. And then my final answer is going to be 0.234 moles per decimetre cubed. Now that's a sensible value because the initial concentration of the acid was very similar. So it wasn't identical, but the concentration of acid was 0.107. So, and they react in a 2-to-1 ratio. So therefore I'm expecting there to be, if they're very similar volumes, which they are, 22.85 and 25 are very close, then I'm expecting my lithium hydroxide to be about double the concentration, because I needed the same volume, but it's 2 lithium hydroxides to 1 acid. So if I got a number that was like 234, you've done something wrong. If you got a number that was 0.0000002, you've done something wrong. So you can self-check this type of calculation. So I wanted to end this video just looking at a similar kind of flowchart that we could use for a titration question if it wasn't giving us all of the steps to do. So at GCSE it probably will step you through, but how would you approach it without those step-by-step instructions, find the moles of this? Well, we're going to do it the same way that we do with the mass and gas questions, because we've always got a balanced equation in the middle that tells us the ratio of the acid and the alkali in terms of moles. So the main difference is that instead of only having one number about a particular chemical, in the example we just did, we actually had 2 pieces of information about the acid. So we actually had the concentration and the volume of the acid. And the norm is that concentration is given in moles per decimetre cubed, and that volume is actually given in centimetres cubed. So one of the steps that we needed to do was to turn centimetre cubed into decimetre cubed, and we do that by dividing by 1,000. That gets us our volume in decimetre cubed. Once we have that volume in decimetre cubed, we can take our concentration and our volume, and we can do concentration times by decimeter cubed, and that gets us the moles. So that's what we did in the first step of that last equation to work out the moles of the acid. We then do the same thing that we did in the mass and the gas questions, which is that we use the ratio. In this case it was 1 mole of sulfuric acid to 2 moles of lithium hydroxide to work out the moles of the unknown. So in the question we just did, that was lithium hydroxide. And then, unlike the other questions, you are normally given one piece of information. So in that question, and it's the usual case for a titration, we also know the volume of the unknown solution. And we know that because we did a titration and we actually carried out the experiment to find the volume of lithium hydroxide. That was the number that we averaged in the titration experiment. That was the value that we used, that mean of the concordant titer values. So again, volume of unknown is in centimeter cubed, and so we need to again do that divide by 1,000 step to get decimeter cubed of our unknown. Once we've done that, we can do moles divided by decimeter cubed to work out concentration of unknown. So our usual information that we're given in a standard titration question is we're given the concentration of one of the substances and the volume, and that's normally the one that's sort of measured out, like the 25 centimeter cubed, and then we're also usually given the volume of the other substance, and that is the one that we get from the burette. So that is the one that has a decimal place because it's normally an average of values and it's not an exact number. From those 3 pieces of information we can work out moles of the thing that we have 2 pieces of information about. We can use the balanced equation to get the moles of the other substance, and then it's just rearranging our concentration equals moles over dm cubed. Occasionally you could be asked, for example, work out the volume given the concentration of 2 substances. So you can go any direction in this by rearranging my moles concentration volume formula. But that's the normal way that a titration calculation goes.